Okay, we're going to do another example now. We can see it's still asking you for cos of x minus alpha, still between 0 and 360, but we also have some different numbers involved this time. So we're going to set out the exact same way. So sine x plus root 3 cos x is k cos x minus alpha. We're going to use our expansion from our formula sheet. And then I like to always rewrite the question at this point. You could do it through, but now this line's really important. You get a mark for this line. It has to be that left-hand side, the right-hand side, sorry, exactly as it is. Right, now we're going to equate them. So we're going to look at the sine x's. So sine x, where's the other sine x? It is there. Right, now there's no number there, so I'm going to put a 1 around it. So that 1 is the same as what's in front of the sine x. So we say 1 equals k sine alpha. And we're going to do the same with the, let's go red, the cos x's, right? Cos x, cos x. We have a root 3 this time. So we have root 3 equals k cos alpha. Now, they're in the right form because sine's on top. No negatives to worry about, so I'm just going to put a wee bubble around them. Right, to get k, we're going to do 1 squared plus root 3 squared, square root, which is going to be square root of 4, which is obviously 2. Okay, we're going to get our alpha next. So to get our alpha, so we have k sine alpha equals 1 over k cos alpha equals root 3. They cancel out. So tan alpha is 1 over root 3. We're going to do our SATC like last time. Do it for both of these. They're obviously both positive, but it's important when we get negatives. We're working in degrees, 30 degrees. So alpha is just that 30. Final thing, go back. So we have 2 cos, go back to the start, remember, x minus 30. Okay, so sine x plus root 3 cos x is equal to that. Okay, we'll do example 3. Example 3 again looks really pretty much the same. 2 differences. You've got a minus there, we'll put a minus this time. So we're going to work our way through it. Okay, so it's a minus this time. And remember your formula, minus becomes plus. Now you need to have the k's at both bits. Obviously, you don't need to put the middle step in if you always remember that both of them have k. But a lot of people don't, I'm afraid. And therefore you would lose a mark. Okay, this is where the equating comes in. So let's go for sine x. Right, sine x is over there. Right, so we have a 2. And what do we have? We have a k sine alpha. So 2 is k sine alpha. Cos x is, right, cos x, cos x. Now this time we have a minus 2. So minus 2 is k cos alpha. Sine's on top. The minus is with the 2, so that's fine. So if there's an issue, if there's ever a negative with the sign or cos, I'll rewrite it. But it's signs on top, cos on the bottom, and it's good to go. Right, so to get k, square root 2 squared plus negative 2 squared. 4 plus 4, which is 8. So root 8, you can obviously change that into 2 root 2 if you wanted to, but we'll just leave it as root 8. Alpha. So what do we have? So k sine alpha is 2. K cos alpha is negative 2. They cancel out. Tan alpha is negative 1. Right, so this changes this bit. So we have, first of all, positive sign. So there and there. Negative cos, right? Where's cos negative? It's negative there and there. So this time we're working in this quadrant. Now you will notice that we're actually working in terms of pi. I'm going to do it in degrees and then I'm going to come back to it. So tan to the minus 1 of 1 is 45 degrees. So alpha will be that quadrant I've just circled. So 180 minus 45, which is 135. Now we need to put that into radians. So what do we know? We know pi over 4 is 45. So how many 45s make 135? Is 3. So therefore our answer is root 8. Look back up, what do we have? Cos of x minus 3 pi over 4. So like trig, you can work in degrees as long as you check the question and you change back the way. Right, final one of this we'll do just now. Example 4. So we've still got a cos expansion. We're calculator this time and we're working in degrees. So churning out your steps. Plus becomes minus. And remember to put that k in there. Oops. And I'm going to equate this bit. Okay. Right, so cos x is cos x, cos x. So we have a 12 k cos alpha. Right, sin x is, what do we have? We have a 5. We have a minus this time, so I'm going to circle, I'll put a square around that. So we have 5 is minus k sin alpha. Now, 2 issues with this. First of all, you can't have the minus with the k. So I'm going to put the sign at the front, and what I'm going to do is move that minus to join the 5. And then I'm going to have 12 is k cos alpha. Okay, and that's the form you want to have in. So to get k, so minus 5 squared plus 12 squared. It's a calculator question, but it isn't Pythagorean triple, so it's 13. Okay, we're going to get our alpha. So we have k sin alpha is minus 5. K cos alpha is 12. Cancel them out. Tan alpha is minus 5 over 12. Okay, so again, going back to these two. So sine is negative, where's sine negative there, and cos is positive there and there. So we're actually in this quadrant this time. So let's get our theta. And that gives us roughly 22.6. Okay, or 23. So alpha is 360 minus that, because we're working in that quadrant. 337.4. So what's our answer to this one? So therefore equals, you can write the whole question out if you want. Right, we had k, which was 13. We had k cos x plus our angle 337.4 degrees. Forget the degrees, it's okay.